So for this video, I'm going to go through just an overview of what a sequence is. So I'll do some vocabulary notation, we'll practice writing out terms, we'll practice finding a general term, and then we'll tell you about arithmetic sequences and geometric sequences. So first off, what is a sequence? So a sequence is just an ordered list of numbers. My spelling down. So, like in general, the most general way we write this would be a sub 1. So we subscript these individual terms. So a sub 1, a sub 2, a sub 3. They have some sort of pattern in there. And then a sub n. And if I go dot, dot, dot at the end, this means we have an infinite sequence. Goes on forever. So these individual items are called terms. We'll talk about the terms of a sequence. A sub n is called the general term. And you're going to kind of think of this like as a function. So if we have the general term, it can help us build out the rest of the sequence. And then n is the index, the index variable. Okay, well, let's go ahead, and I guess that's it for vocabulary. Oh, notation. Sometimes, and I'll probably not be good at this, but we can use our set braces to denote that we have a sequence, and we can put that general term on the inside, and that will let people know who see this say, hey, this is the pattern, write out the sequence. Okay, so let's practice writing out some terms. If I give you this a sub n, this general term. So let's say, I'll say write out the first 6 terms in the sequence. So let's say our a sub n is 2 to the n. Now, unless it's specified, n is going to start at 1, and it counts by integers. That's a good thing to put up here by your index variable. Starts at 1. It doesn't have to start at 1, but if it doesn't start at 1, somebody has to tell you where it starts, and then it counts, So it's just, integers. Okay, so if our general term is 2 to the n, what's the first term, It's going to be 2 to the first. And the second term is going to be 2 to the second. And 2 to the third, and 2 to the fourth, and 2 to the fifth, and 2 to the sixth. And this, of course, we could write out what those are. Now, this sequence could continue on, forever. Okay, how about this? What if a sub n equals sine of n pi halves? Can we write out this first 6 terms of this? I don't know, let's see. I'm going to draw a quick little unit circle because that's how I have to find my sine values. Remember, it's the y values as you go around. So n equals 1. So I have the sine of pi halves. So I'm up top. So that'll be 1. N equals 2. So then I have the sine of 2 pi halves. So that's the sine of pi. So now I'm over here. That's a 0. You with me? So if n is 3, I'm doing the sine of 3 pi halves. 3 pi halves is down here on the unit circle. The sine value, the y value, is -1. Let's see, here's 1, 2, 3, n is 4. So now I have the sine of 4 pi halves. So that's sine of 2 pi. 2 pi brings us over here. The sine value here is 0. And then we go around again. So 1, 2, 3, 5. 5 pi halves takes us back up top. That's a 1. And 6 pi halves, that's 3 pi. That's over here at a 0. And you can imagine, right, this pattern would just keep repeating itself on and on. How about this? What if my nth term, my general term, is negative 1 to the n times n squared? What are the terms of that sequence going to look like? If you want to pause and try to write them out, that'd be great. Okay, here we go. So n equals 1. So I have negative 1 to the 1, that makes it negative. And then 1 squared is 1. Now n equals 2. So right, it goes in both places, right? I'm treating it just like a function. So n is 2. I have negative 1 squared, that makes it positive. And then 2 squared is 4. N equals 3. Negative 1 to the third, right? Negative 1 to an odd power makes that negative. And then I have 3 squared, that's 9. Negative 1 to the fourth is positive, and 4 squared is 16. Negative 25. Positive 36. And at some point, right, you see the pattern and you can start writing out the next ones. Okay, let's go ahead and try to go the other way. I'm going to give you the sequence and you're going to try to come up with the general term. So now we're going to find the general term. So let's say my sequence is 1/2, 1/4, 1/8, 1/16, ... What is that a sub n? Right. And there are a couple of ways. These are not sequences, and when we get to series, are not necessarily unique. Sometimes there are many ways you can write them. So I might write this as 1/2 to the n as my nth term. Maybe you wrote yours as 1/2 to the n, also perfectly fine. All right, how about if I have this one? Negative 1/2, positive 2/3, negative 3/4, positive 4/5, negative 5/6, comma, ... So one of the ways, if you're struggling with finding that nth term, is to see, okay, do I know what number comes next? Right? Could I just write down that next number and kind of think of how you got there? So let's see, I'll use the a sub n equals this time. So the first thing I notice is that the sign is changing, and it looks like it's negative on the odd numbers. So that'll be a negative 1 to the n. Okay. If it's negative on the even numbers, you just need to do this to an n plus 1. Okay, that's the workaround. And then let's see, my numerator, so I've got a fraction, and it's 1, so these just look like the numerators are n. We can do that. And then the denominators are just one more. Oh, well, that wasn't bad at all. There we go. Okay, so now we can write out terms if we are given the nth term, or we can find the nth term, right, if we're given the sequence. Now, sometimes a sequence can be given using a recursive model. And the recursive model means that subsequent terms are based on previous ones. So for instance, I don't know if you guys know the Fibonacci sequence, right? That is a recursive model. So what you have to do is you start with the first 1 or 2 terms. So in this case, we'll just write out Fibonacci's. So a sub 1 is 1, a sub 2 is 1. Now, for everything else, a sub n equals a sub n minus 1 plus a sub n minus 2. So let's see how that's going to work. So when we get to n equals 3, so a sub 3, let's just write out what that's going to be. I'm going to have a sub 3 minus 1 plus a sub 3 minus 2, so that's just a sub 2 plus a sub 1. So for us, that's going to be 1 plus 1 is 2. So a sub 3 is 2. So then what would a sub 4 be? So I have to go back and I use this model. It's a sub 4 minus 1, so this is a sub 3 plus a sub 4 minus 2, a sub 2. So we're going to add a sub 3 plus a sub 2. So that's 3. A sub 4 is 3. I know you think it's like, well, is it just going to go up by 1 every time? Okay, well, here we go. A sub 5, stuff's going to start happening. A sub 5 is going to be a sub 4 plus a sub 3. So a sub 4 is 3 plus a sub 3 is 2. So that's 5. So instead of doing this anymore, right, I don't know if you guys saw what was happening, but we just add the two numbers that came before, right? So a sub 6 is going to be the sum of the two previous numbers. A sub 7, sum of the two previous numbers, etc. So when you write out the Fibonacci, oh, I didn't look up the spelling, I hope I got it right, sequence, 1, 1, 2, 3, 5, 8, 13, right? An infinite sequence keeps on going. Okay, so recursive model. Sometimes it's just based on the 1 before. Sometimes it's based on 2 before. But right, you just have to start writing out terms and then look back. So an arithmetic sequence is a sequence where there is a common difference between consecutive I wanted to put a Q in there, terms. Writing all that sequences. Okay, so for instance, 2, 5, 8, 11. Do you know what number comes next? Right, what am I doing each time? 14, 17, 20, ... Yeah, exactly, right? So the common difference is 3. So we could say that D, this common difference, right, is a sub n minus a sub n minus 1. Okay. And then could you write the nth term for this arithmetic sequence? Right, so each time you go up by 3, right? So you could say maybe a sub n equals 2 plus 3 times n minus 1. If we say that n is going to start at 1. So that n equals 1, right, we'll wipe this out for my first one and get me the 2. When n is 2, I'll add 3. When n is, right, 3 minus 1 is 2. Okay, like I said, they're not unique the way you're going to write out these nth terms. So this is an arithmetic sequence when you have to add the same amount, right, to get to the next term. The other special one is called a geometric sequence. And for a geometric sequence, right, there is a common ratio. Not rate, ration, ratio between consecutive terms. So an example of this might be 5, 1, 1/5, 1/25, 1 over 125, so what's this common ratio? So if I do division between any two subsequent terms, I get the same result, right? So that common ratio, so a sub n divided by a sub n minus 1 is a common ratio. For in this case, right, it would be, or is, 1/5. And you can check it between, right, any pair. So 1/5 over 1. 1/25 over 1/5, I can tell that you're not quite sure. So 1/25 divided by 1/5, right, just to make sure. The 1/5 on the bottom flips and multiplies. Reduce your fractions. And there's that common ratio of 1/5. It's what